In this video, I am going to show you how to sketch multiples of a vectors, scalar multiples, that is. So let's review the concept of a scalar. A scalar is just a number such as 2 or 3 or 4 or minus 10 or negative pi. Anything of that form is a scalar. Okay? There's no implication of direction. It's not negative pi west, not negative pi east, or anything like that. It's just negative pi, 2 or 3, 4, negative 10, 2.98, and so on. Okay, these are just numbers. So let's take a look. We are going to work with the following vector, vector v, and the components of this vector are 2, 3. And we are going to sketch some scalar multiples of this vector. So how do we do this? Well, let's draw a coordinate system so that our vector is more concrete and it's located somewhere at least, right, for reference. So I'm going to set up a coordinate system in the page. And I'm using grid paper so it's easy to trace good looking lines. There we are. Okay. And our vector, we are told, has components 2 and 3. So you count 1, 2, 3. I'm taking 2 spaces here as 1 so that it's bigger and easier to see. 1, 2, 3, negative 1, negative 2, negative 3, negative 1, negative 2, negative 3, negative 4. Okay, so here we have a little coordinate system. This is, of course, the x-axis. This is the y-axis. The vector has components 2, 3, so let's draw them in. So that means 2 along the horizontal, and then 3 along the vertical. So it looks like this. So our vector, finally, we can say is the arrow that goes from the origin to there. Okay, this is our vector. So let's label it. This is the vector v, whose components are 2 and 3. And it's located within this coordinate system. And now let's take a look. We are first going to draw the following scalar multiple, 2 times v. So how do we do it? 2 times v means you take 2 and you multiply each component of v by the 2, so it turns into 4, 6. Okay, so to draw a scalar multiple, what you would do is draw a next component of 4 now and a y component of 6. So draw a next component of 4 along this one, and then a y component of 6, so that will take you up to here. Okay, those are our 2 new components. And then draw the new vector. There we are. Okay? So this new blue arrow represents double v. This is 2 times v. Okay? There we are. Oops. All right. So all you are doing is you're beginning with v being 2, 3. When you take 2v, what you're doing is multiplying the 2 by 2 and the 3 also by 2, which gives you 4, 6. So you've got a new vector with an x component of 4 and a y component of 6. Draw them, and then draw a new arrow to indicate 2v. So you see that the length is double the previous. All right, let's see what else we have here. What if you were asked for negative 2v? Same concept applies. Negative 2, 2, 3, the original components of the vector. The negative 2 times positive 2 is negative 4. and negative 2 times 3 is negative 6. Here we are. So these are the components of the vector that is double V, but made negative. So let's mark those. So you're going to go 4 to the left, because that's negative. Then you're going to go down 6. So negative 4, negative 5, negative 6. Alright, so let's see here. Where are we? 1, 2, 3, 4. Okay, so we are just about here. Yeah, so this is the y component of the new vector, which means negative 2v lies along this line right there. That's negative 2v. Okay? So this vector is negative 2v. So each of these that I've drawn is an example of a scalar multiple of the original vector v. This one is double this one, and this one here is negative 2v. So it's got double the length and points in the opposite direction. Okay, so these are the pictures that go with these mathematical operations. 2v, double each component. Negative 2v, double and make negative. And then draw correspondingly. And of course here, what's common is to take and perhaps draw a unit vector in the direction of v. So to review that operation, first you would need the following. First, you've got to find the length of v. So the magnitude of v we find using these double bars like this. That's the symbol. And of course we use the Pythagorean theorem because, as you can tell, it's a triangle. So we have now 2 squared plus 3 squared. That's the Pythagorean theorem, nothing else. So we get 4 plus 9, which is then just the square root of 13. So that is that. And then what we have next, of course, is you take your vector v. We'll first use a new letter u to indicate a unit vector. And remember, a unit vector has length 1. So you take your vector v and divide by its magnitude. So this gives 2 comma 3, and the whole thing is divided by the square root of 13, and then this is what we call a unit vector in the same direction as v. And of course then to draw that vector, that's just another scalar multiple of v, that's all it is, if you think about it that way. To draw that vector, what we do is we draw an arrow roughly here, okay? There we are. So this is the original vector between my fingers. First we doubled its length, it gave us this vector. Then we doubled its length and we flipped it, so it gave us this vector. And now we have a little unit vector, the red one here, but it's still along the same direction as v. The only difference is that its length is 1. Okay, so these are the fundamentals of scalar multiples of a vector. Notice the concept, the key concept is all of these lie along the same line as the original vector v. Right? They are all along the same line. If the scalar is positive and greater than 1, we stretch. If it's positive and less than 1, we compress. If it's negative, then it flips and moves that way. There you go. Thank you for watching.